I guess there are really kind of three main questions that are really asked in real estate, and the first one is around investment. So where do I invest? If I've got this plot, what should I make it into? That's a kind of an investment kind of scale question. The next question is around, I've got this kind of, I've got a site, or I need to design a brief. What kind of place should this be? What's going to attract people? And then the third question is really measuring measuring the impact of those places. So I'll focus on the first question to start with and talk a little bit about the methods that you can apply to those scales. So in terms of working out where is the next great place, or if you wanted to make a particular kind of impact or a particular kind of return on your investment, where are those locations going to provide, or what locations are like another location? So if say that, taking the example of, in London, for example, if that there's a hot new neighbourhood, I think, Peckham had, for example, an incredible amount of investment over the last few years. If that it's going to be a hot new place, what are the other places that are very similar to that place that then you can, might be the next new thing that you should invest in now? So these kinds of methods look at that question on a large scale. Predictive analytics is an interesting field, so that's really looking at time-based data. So where you have a series of data over time, and this is so what is difficult, I guess, with this area is actually getting that data in the first place. So time series data probably is limited mostly to financial data or to demographic data. There's very little time series data on many other things. I mean, you can get movement data on the time series, for example, but sometimes things aren't collected and collated, kind of a neat package in the same way that things like financial and demographics are. But still, you can get some quite interesting insights from demographic analysis in a time series sense, and then also the financial analysis in a time series sense. So one example that we're using this for is looking at future casting for particular types of investment, where you might be wondering what people might want in 15 years time as opposed to what they're wanting now. And so you can start to look at the trends in patterns and start to see, okay, well, this is where the market is heading. Real estate is a long-term play, so predictive analytics comes in really helpful in this sense. Clustering models we've used on quite a number of different projects, and it's really looking at where you have so for example, in this case, which was, I think, another Bayfield seminar that one of our team ran, we looked at affordable housing. We looked at a number of different plots across the city and worked out which locations would be the best and the most suited for affordable housing based on the kinds of spatial and demographic characteristics that were in that location. So, for example, if it had really good access to transport, or if it had good access to schools already, or if there was, a certain number of children within the neighbourhood, or a certain amount of deprivation, where affordable housing could really make an impact. That's what the kind of things that we base this measure on. In this case, we mostly focused on spatial because we wanted to provide an equitable opportunity. So we really looked heavily at what were the most what were the kind of opportunity areas that were the most spatially spatially kind of suited to affordable housing and creating opportunity for those residents. We've used that clustering model also in the sense of, that's what you would use if you want to find one place like another place. You would use an unsupervised machine learning method to be able to kind of pull the characteristics of that place that are important and be able to then see, okay, what other places in the city are very similar in a spatial sense, in a social sense, and possibly also in a financial sense if you're also looking at particular kinds of opportunities that are maybe under slightly under the market value at the moment. Regression analysis, that's a supervised machine learning method. So really you're kind of training, you're kind of looking for certain things. You're saying, okay, well, you know, this, you're kind of setting the parameters, if you like, of the search or of the conditions under which you want to, you know, find other data points that correlate to that, and the amount in which they affect each other. So that's really where you might use this, for example. So we've looked at this in terms of retail spaces, looking at the spatial metrics of retail, and I'll show you that model that we've used in a further slide. So looking at the kind of spatial conditions of that retail unit. So, you know, does it have a long frontage, how accessible it is to the entrances, where it's positioned in relation to other units, and how and what kind of footfall and flow would be kind of moving around that unit, and also their kind of movement potential of that unit, and then correlating that with things like rental return. And then you might, particularly in the case of where you were turning to, like where we're kind of moving to more turnover leasing models, that is a really, you know, kind of that the footfall drivers and the kind of the design drivers of retail become so important, because basically that's what's, you know, that's kind of what's driving your turnover as much as brand identity is as well, of the actual kind of actual business that's in place. So that's a kind of example of where you would use regression. Geospatial filtering is a tool that we've developed to help you, help clients manage their own data and sort and filter through their own data. And I'll take you through that in a bit later.